Okay, I just wanted to talk about inequalities quick, and I'm kind of scummy because it's hot in Iowa and we took our dog for a walk. But um, with inequalities, we did this with absolute values, remember? And the two options with absolute values were, you draw the V and you draw the line, right? And then you're like, oh, I'm less than zero, so I'm trapped between whatever, or I'm going off to infinity and I'm up here if I'm greater than zero. Okay. So remember, parabolas, are going to, I mean, it's a function, right? It's going to be kind of similar. So I am going to, again, we always want these to compare to zero. It's easier to compare to the x-axis than some line that's in space. But so I want to move the 12 over by doing the inverse, right? -12, -12, or minus to get that. Okay. What is the inverse of all multiplied out? It would be factored. And what factors of 12 can give me a 1? Well, that would be 4 and 3. And I have a 3 and a 4. Let's see, 4 and 3. I want this guy to be a negative and this to be a positive because I want a negative 4x and a positive 3x to get that negative 1. And again, we want this. Okay, so at this point, we have our key points. When set this equals 0, we get 4. Set this equal to 0, and we would get x equals -3. And again, always do the inverse to get those. That's how I'm doing that. Okay, so if I want to graph this, I can. I know that it is going to cross. Okay, these are x-intercepts. These are zeros. 1, 2, 3, 4. It's going to cross there. -3, 1, 2, 3. Let's see, when x is 0, I know the y-intercept is a -12. Now, I could find the vertex, right? I mean, I could go opposite of b over 2a, or I could complete the square, whichever one. Opposite of b is 1, 2 times a. So it looks like somewhere down here, and again, I don't need to know exactly what the other value is, the y value, because that's not really what I care about. I'm not looking for the max or min or anything. What I'm looking at is how does it compare to the 0, right? Like, how does it compare to the x-axis? Okay, well, I want to know, not here, I'm looking at my new function. When is my function greater than 0? Well, greater than is above, right? So I want to know, oh, it's above here and it's above here, and it can equal, so those are solid. So what are my x values where it's above? -infinity. And then it stops having x values at, what is that, -3 brackets. And then I'm going to skip, right? Because none of these are answers. I'm going to pick up, this is included. So I'm going to pick up at 4 and go off to positive infinity. So that's how you can do it with a two-dimensional chart, similar to what we did with absolute values, okay? If you don't like two-dimensional, we can go one-dimensional. And when you do a one-dimensional chart, what you're really doing is just looking at the x-axis. So you're not really paying attention to the y-axis, okay? All right, so let's do this. We have a -3 here, which is a key point. It can equal, so I'm going to put a solid point and 4. Okay. All right, so what you're going to do in this method, you're going to just test points to see if it has a positive behavior or negative behavior. Because if you notice, we want the output, right? This is my function. We're going to sub in an input. It's going to spit out an output. We're looking for when the output is either equal to 0 or positive. That's what we want. All right, so I am going to do some test points. You always want to test 0 if you can. So 0 is in the middle of here. So let's test 0. 0 squared minus 0 is a -12 greater than 0. Okay, because these guys would be 0. Is a -12 greater than 0? The answer is no. So that is not an answer. None of that middle, nothing in between there will be. All right, let's test something over here. Sub it in. 5 squared is 25. -5 minus 12. Now, technically, I can do the math. 25 minus 5 is what, 20, and I could get, what is it, 8? I don't even care that it's really 8. What I care about is the fact that it's positive, right? It is a positive output. And is that what I want? Yes. I want the output of this to be greater than or equal to 0. So all of these, anything in this region is all going to end up positive, not just 5. Okay, let's test over here. Again, I'm going to test a -4. A negative times a negative is a positive 16. If you're going to type that in a calculator, again, with negatives, you have to have a parenthesis there. So a negative times negative is 16 minus a -4. So minus a -4 would be a +4. and then minus 12. And when I look at that, I'm like, oh, it's positive. Again, I don't care what it is. It looks like it might be 8 again, but I don't care. So all of these have positive answers. Now, here I can see that it's greater than 0. Here it kind of helps with the interval notation. So do you see how you're starting at negative infinity for x values? You're quitting at a negative 3, which is a bracket. Pick up on the other side, you're starting at 4, which is a bracket, and you're going off to infinity. So either way, you're going to get the same answer. It's just one is a two-dimensional graph, like what's visually happening with the function. The other is just looking at key points and doing that. All right, okay. Let's look at the next one, okay? So let's look at this guy, kind of a rational function here. I can also do a two-dimensional graph. We're going to do more with this in the next module, so I don't want to, I don't know, spend too much time on this, but my vertical asymptote is whatever causes 0 there, which is a negative 2. So at a negative 2, I'm going to have a vertical asymptote. My horizontal is what happens when I reduce that, which is 1. So I'm going to have a horizontal asymptote at 1. And with rational functions, you usually have stuff here, 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 something like that. Okay. And what we could do is we could sub in points to kind of see how this behaves. So if let's say, oh, I don't know, let's set it equal, let's figure out some intercepts here. If I set it equal to 0, I would multiply both sides by x plus 2. And notice that is going to equal 0. So really, and that makes sense, right? If something equals 0, as far as a fraction goes, the numerator is going to be the 0. You can't have 0 divided by 0. So if this is 0, the whole thing is 0. So add 3. When x equals 3, okay, so if I'm over here, 1, 2, 3, that's an x-intercept, okay? I could sub in x equals 0 to find a y-intercept. So let's do that. So if I sub in, let's just put a 0 in there. That's the other part of the function, and put a 0 in there. I get a negative, what is that, 1.5, negative 3/2. So I'm just treating that as a function and trying to figure out what's happening. So when I sub in an input as 0, I get a negative 1.5. So that's down there. Okay, so right now it's looking like over here, this guy's, doing something like that. And the asymptotes are going to kind of keep him in. All right, let's see what's happening over here just to kind of get an idea. Where are we? Maybe let's just sub in, I don't know, negative 3. All right, a negative 3 minus 3 and a negative 3 plus 2 is a negative 6 over negative 1. That's a positive 6. So let's see, 2, 3. So we're up here maybe. Okay. All right. Let's sub in a negative 4, just see what happens. Negative 4 and a negative 3 is a negative 7. And that would be negative 2. So that would be what? Positive 3.5. So somewhere in here. So this one, and again, this is just a sketch. This is not pretty. It looks like it's doing something like that. All right. So my original problem is saying, okay, this funky graph, when is it greater than 0? Okay. So where's my 0 at? Well, my 0's right here. Okay. So let me grab a marker here. My 0 is my x-axis. Right there. Okay. So it wants to know, when is it positive, right? Again, positive, or when is it greater than? Well, this part of the function is definitely greater than the orange line. So what is that? That is negative infinity for x's, and this asymptote was what? At a negative 2. And it can't land on that asymptote. That's like a brick wall, okay? And then on the other side of that asymptote, it's like, well, this stuff is all negative, right? Like these values down here are negative, right? Now here we get 0, which we're saying that's okay. So 1, 2, 3. So that would be a bracket at 3 going off to infinity. All right, so that's how I would do it with a two-dimensional graph. And if I go to Desmos, I'm going to pause here a second so you can see what Desmos looks like. Okay, so mine was just a rough sketch, but here you can see that Desmos graphed it. So there's the two parts, and then here is the x-axis. And so you can see all of this stuff is positive, and then starting here, the red part is positive, okay? All right, I'm going to show you with test points. So if you're like, Julie, we have not learned how to do these graphs yet, and I have no idea what I'm doing, let's do it with test points. So I'm going to pause and we'll do it that way. Okay, if we're doing test points, we have to kind of pay attention to the x-axis because we're only dealing with that. So one thing that can cause problem are asymptotes because it's undefined there, right? X cannot be a -2. Dividing by 0 math, 8 divided by 0 is undefined. That is a big no-no. So X cannot equal -2. And that is a vertical asymptote, which we'll learn more in the next unit. But just know that -2 is a no-no. And so we're going to put an open dot there because it just can't equal it, right? Even if you're like, but this says greater, yeah, but it can never equal 0. So -2 is out. All right, what else do we have going on the x-axis? Well, we have x-intercepts, okay? And remember, an x-intercept has to have a number in the x spot and a 0 in the y spot. So if I view this as a function, I want to know when this function equals 0, and we did that earlier. But remember, I'm going to multiply both sides. The inverse is to get rid of division is multiplying. But remember, really, if the numerator is 0, the whole thing is 0. So x minus 3 equals 0. Do the inverse, add 3 to both sides. Okay, so we get 3. Now 3 is a legal answer because 0 divided by 5, if I sub 3 in, 0 divided by 5 is okay. So I'm going to put my 3, and that's a solid point. And we're going to do what we did with the quadratics. You're just going to do test points. So you might not even know what the graph of this thing looks like. And it's okay, right? Because you can still answer the question. Sub in a 0. So what do I get? If you sub in 0, you get a -3 over a +2. That's negative, and we want positive numbers, right? We want greater than or equal to 0. This is negative, so this is a big no. We are not there. All right, let's sub in over here. Let's try 4. If I sub in 4, I get 4 minus 3 is 1. 4 plus 4 plus 2 is 6. That's positive. We do want positive. So all of this stuff over here, all of this is all going to be positive. So it's all going to work. And then over here, let's sub in, say, a -3. -3 minus 3 is a -6. -3 plus 2 is a -1. Negative divided by negative is a positive, which again, we want 0 or positive. So all of this is good. And again, the advantage of this is your interval notation comes right off. This is at -infinity. This is a -2 now, not inclusive, okay? And I don't know, did I catch that on the other one or not? I might have to go back and fix that. Nope, I caught it. Okay, just making sure I was right. And then over here, we're going to skip the middle, union, and then we're going to pick up bracket 3, and then this one's going off to infinity. So we should get the same answer either way, whether you do a two-dimensional graph or just the x-axis and kind of do the key points on that. Just know on this one, if you have something like, x plus 4, and you have x minus 3 and x plus 2, x minus 8, you do have to get it greater than or equal to 0. Then you would have asymptotes, vertical asymptotes at a +3, whatever causes 0, -2, +8, and then you would have to set this equal to 0 to get a -4. So you could, like in this situation, I could have one at 3, that's that one. I could have one at 8 there. I could have one at -2. And if x plus 4 equals 0, I get a -4. And I would have to test things in between, every single thing, okay? If this does not equal 0, you might have to move stuff over and do some of your rational fractions. So if you have something like, I don't know, greater than or equal to 2, you might have to get a common denominator and bring that over. I'm going to distribute that while I'm at it. Is greater than or equal to 0. And then combine these. So add the opposite, negative, negative, so -x minus 2. And then from there, you might have to factor and do all that work. So that's why you did some of that work early in the review to help with situations like that. All right, hopefully that helps. Give the homework a try. If you need help, let me know.